Example 15 is a question that needs us to do some observation about the questions, the terms, before we can think of something, some way to solve the question. Now we're given that the R term of a series is in this form. Find the sum of the first n terms. Sum meaning we need to add all the first n terms together. When we see a problem like this, and if we are at a loss as to what to do, remember, don't give up. What we should do is just try to understand the problem as much as we can. Now since we are asked to sum the first n terms, when we need to sum the terms, why not just ask ourselves, what are the terms that we need to add up first? So we see that the variable here is R, meaning by substituting different values of R into this given expression, we will be able to get different terms of the series. So we start with R equals to 1 to get the first term. When R equals to 1, we see that the first term is given by 3 power 0 plus 2. That's what we get when we substitute R equals to 1 into the expression. The second term, when R equals to 2, is given by 3 power 2 minus 1, that is 3 power 1 plus 2 times 2. Well, if there's not sufficient for us to do anything yet, we'll say, why don't we try a few more terms? The third term, when R equals to 3, is 3 power R minus 1 will be 3 minus 1, that gives 3 power 2 here, plus 2 times 3, that gives us the third term. Then we proceed. The fourth term is when R equals to 4. We substitute in R equals to 4 into the expression, we get 3 power 4 minus 1, that's 3 power 3, plus 2 times 4 here. Then we look, hey, do we see some pattern here? Well, let's handle our impulsivity. We don't judge anything yet. We are asked to find the sum of the first n terms. Maybe we should just suppose that we keep substituting in different values of R until when R equals to n for the n terms. So how does the nth term look like? We know that's when R equals to n, so that should be 3 power n minus 1 plus 2 multiplied to n, right? So that will be the last term that we add. Now when we concentrate on all the terms that we have written down now, when we add from young, we know that it is more logical for us to add like terms together. So what are the terms that look alike here? It's not hard for us to see that the terms with base 3 are the similar terms that we should be adding, right? And the terms with 2 multiplied to 2, 2 multiplied to 3, 2 multiplied to 4, and so on. The terms on the right side, those are another terms of another form. So if we look at this and we try to add those terms highlighted in yellow together, what do you see? If I write them out clearly by the side here, if you consider this, what do you see here? Does it ring a bell? What pattern do you recognize here? Hey, we actually have a geometric progression with first term as a, common ratio with first term a as 3 power 0, which is 1, common ratio as 3. Number of terms will be the number of terms that we are adding, that is n. Okay, so when we add up all the terms with highlighted in yellow, we will be having the sum of the first n terms will be a r power n minus 1 over r minus 1. So we'll be having half times 3 power n minus 1. Okay? So when we present our answer, we will present it neatly later. Okay, let's look at the part highlighted in green now. If we look at all the terms highlighted in green, we will have this. So when we try to add these terms together, remember we usually factor out the common term first, so we factor out 2. That leaves us with this inside the bracket. And when we observe this, what do you see inside the bracket? Hey, we actually have an AP with first term a as 1, common difference as 1, number of terms as n. Since we are adding n, the first n terms of the series in the first place, so when we have sum to n term of an AP, it will be n over 2. Now remember the formula n over 2a plus last term. So the first term is 1, the last term is n here. So when we present our final answer, we will just write over here as 3 power 0 plus 3 power 1 plus 3 power 2 plus all the way to 3 power n minus 1 plus 2 plus 2 times 2 plus 2 times 3 plus up to 2 times n, and we just write it as equals to this, whatever we have written down earlier, plus 2 outside, oops, 2, remember we factor out, which is 1 plus 2 plus 3 plus all the way to n here, and we will have half 3 power n minus 1 plus 2 times n over 2, 1 plus n. So we will end up with the final answer as half 3 power n minus 1, then plus n and plus 1 here. That will be the final answer. Thank you.